Okay, let's talk about duration. And before we get into duration, I want you to think about the following. Let's say that Coca-Cola in September of 2011 issued a 10-year 6% coupon semi-annual pay bond, and that the market decided that the yield to maturity should be 6.1%. So to get the price of this bond, it's the $30 over 1.0305 plus $30 over 1.0305 squared, and do this all the way out to it's finally 1030 over 1.0305 to the 20th, because it's a 10-year bond, right? And so the price will be $992.60. Let's say a year later, September 2012, Pepsi comes along and they issue a 9-year bond at a 7% coupon, and it's a semi-annual pay as well, and the market has decided that the yield to maturity should be 7.1%. So what happened over the course of, and let's say, by the way, that Pepsi and Coke, in the blind taste test, you can't tell the difference. So the companies, just say for our purposes, are essentially the same risk, same everything. So you really don't care if the bond is issued by Coke or Pepsi, you just care which one is promising you more money. So let's say over the year, yields went up 1%. So Coke issued last year at 6% because they knew yields were about 6.1 to have a bond, at a slight discount. And this year Pepsi issues at 7% because they know yields have gone up. So the price here is 35 over, this is 1.0355 to the first, 35 over 1.0355 squared. This is a 9-year bond, so it's 1035 over 1.0355 to the 18th, and that is, if I'm looking at the right number, 993.43. Alright, so which bond would you rather own now? Would you rather own the Coke bond or the Pepsi bond? And so what's happening, this has already been paid, this has already been paid, and now this is, goes out 18 more years. We're getting this has become 1 year out. So anyway, or 1 6-month period out. So these are the payments you'll get from Coke, $30 for 9 years and then $1,030 at the end. Or would you rather get the 35 from Pepsi? And the answer, of course, is I'd rather get the 1,035 from Pepsi. But you would still like to have a bond that pays $30 every 6 months for 9 years. But now you're going to change the yield to maturity. You're going to pay less. I'm not sure exactly how much less, but I know I'm going to pay less money for this now. Does that make sense? Because given the choice, you prefer the Pepsi bond, but you still would like to have the Coke bond, you're going to pay less money for than you would, I should say less than this $993.43. So the only change that you're going to make here is now the price of this Coke bond is going to be the $30 divided by the new yield. And this goes out, instead of 20 payments, it goes out for 18 payments. 0.355 to the 18th. So that price, so right over here, is $927.76. So what do we know happens to bond prices over time? If yields stay the same, they tend toward 1,000. So this should have gone up in price toward 1,000, but yields went up, which means bond prices went down and went down to $927.76. So that brings the question we're getting to today. We know if yields go up, bond prices go down, and let's look at some comparisons here between a 0 coupon bond and a 6% coupon bond. So both cases, 10 years to maturity. We're going to assume semi-annual compounding. we're going to have a yield to maturity of 6.1%. So if we have a 10-year bond, I'll write this in the calculator notation, there are 20 payments, and let's say that it's a 6% coupon bond. That's $30 for the payment. Future value is $1,000. There's your payout rule. The yield to maturity is going to be half of 6.1%. That's going to give me a present value, or price, of $992.60. If we have a zero coupon bond, everything's identical except this is a zero coupon bond. The price is of course going to be less. It should be $1,000. Hang on. And interest rate still 6.1 divided by 2. Plug in the price, the present value. It's going to be $548.33. So what happens if yields rise? So yields were at 6.1 and then immediately they go to 7%. How does this change what we're doing? Well, this is going to be 7% divided by 2. The payments are all the same. The price is going to go down, right? Yields went up, so the price is going to go down. This goes down to $928.98. The yield went up here. The payout promises are still the same, so the price goes down to $502.57. And kind of what we want to get at today is this. I know that if yields go up, prices are going to go down, and if yields go down, prices will go up. So I have bonds in my portfolio. I'm exposed to two types of risk: interest rate risk and default risk. Now, those are the two we want to think about. Default risk, you know, is the company able to pay what they promise? And we're saying, let's assume that it's equal for Pepsi or Coke or whatever, so assume the default risk is equal for both bonds. And now I'm just exposed to interest rate risk. So if interest rates go up, bond prices come down. So which bond would I prefer to have? Would I prefer to have the coupon bond, so let's call this the 6% bond, or the zero? Well, let's see how the price has changed. Our holding period return is going to be $928.98 over $992.60 minus 1, which is minus 6.414%. Our holding period return over here is going to be 502.57 over 548.33 minus 1, which is equal to minus 8.346%. So notice the zero coupon bond that has identical maturity had a greater drop in the price percentage-wise than the coupon bond did. So I want to be able to figure out, if I think rates are going up, which bond should I buy? So they all have the same default risk and all that stuff, but which bond should I buy? I need a measure of that. And we know that long-term bonds are more sensitive to interest rate changes than short-term bonds. So I should put it this way: long-term bonds tend to be, not always, but long-term bonds tend to be more sensitive to interest rate risk than short-term bonds. But I need a precise measure of that, and that precise measure is duration. Well, pretty precise. Frederick Macaulay came up with this, and the way we measure duration, let's just assume for now annual compounding to make this a little bit easier. So what I'm really trying to do is find the average life of the bond. So if I think about a 4-year bond that has an 8% coupon, payments are 80, 80, 80, and 1,080. Well, that's not really one. When I buy a security, I can think of it as buying not one security but 4 securities to make those 4 payments. So the longer term the bond, in general, the greater the sensitivity to interest rates. But since these cash flows come before maturity, that makes the maturity of the entire thing a little bit shorter than 4 years, right? Because you're getting your money back, some of the money back, before 4 years is up. So can I come up with a precise measure of that? I want the weighted average life of the bond. So that's what duration is for a plain vanilla bond like this, the weighted average life of the bond. So what Macaulay said to do is take the present value of these cash flows. So let's say that the yield to maturity, and we're going to say that all time periods have the same interest rate. So the yield on a 1-year bond, 2-year bond, 3-year bond, 20-year bond is all 10%. So I take the present value of each one of these, 80 divided by 1.10 squared, 80 divided by 1.10 cubed, and 1080 divided by 1.10 to the fourth. I do the math. This is 7273. This is 6612. This is 6011. This is 73765. The whole thing is 93660. So think of it this way. I'm buying a bond, and I'm paying today. I paid $936.60 for all of it. But the portion that matures in 1 year, the coupon payment that comes in 1 year, is worth $72.73 to me. The one that comes in 2 years is worth $66.12 in present value terms. This is worth $60.11. This is worth $737.65. So I want to know on average, when does the value return to me? So think of this. I'm going to erase this part right here. Think of this as a seesaw, and think of the value of these payments as weights. So the fulcrum to make the seesaw balance would be somewhere right around in here. That's the average life of the bond. So mathematically, to work that out, rather than just eyeball it, to mathematically work that out, as to the following. This is a total value, and I want to know the weights. So the weights of the total $936.60 that I spend for this, what percent of that is spent to get this first $80 payment? And what percent of the total price of the bond is spent to get the payment that comes in 2 years, and the payment that comes in 3 years, and the payment that comes in 4 years? So this is 0.077. Got 4 decimal places. This is 0706. This is 0642, and this is 7876. These will add to 1 because, I'll think of it this way, I'm paying 7% of the price of the bond for the first payment, 7.06% of the price for the second payment, 6.42% of the price for the third payment, and 78% of the value of the bond comes from the last payment that it makes. So these are the 4 payments, and the percentage values that adds to 1. To get the weighted average life, I take the time multiplied by the weight. So this times 1, the next one times 2, the next one times 3, and that's 2.5, and this last one times 4, 3.1503. Add this up. This is 3.5617. This is equal to the duration of my bond. So this is the final answer that I'm looking for. Let me clear some things out. So this term with a D is what we'll call duration. There's another term, D star. D star is modified duration. And sparing you the calculus behind all this, D star is equal to D over 1 plus Y. And what Frederick Macaulay says, I can predict the change in the price of the bond by this equation. The negative of the modified duration times the change in yield times the initial price. So in this case we have the modified duration, work it over here, is 3.5617 divided by 1.10 because that's my yield, and that comes out to be 3.2379. So my modified duration times the change in yield. So let's say that yields go from 10% down to 9.5%. Alright, so if bond prices go down, if yields go down, bond prices go up. So a drop from 10% to 9.5%, the drop is negative, and it's going to be 0.005. That's 50 basis points, so make sure you get those terms, 50 basis points times the price of the bond. This is 60, will be $15.16. So this is saying if yields go down by 50 basis points, this particular bond will increase in price by $15.16. I know that because I know the sensitivity of the bond price to interest rates, and that's measured by duration, and more specifically by modified duration. So if you were to put in your calculator the new numbers here, so you're putting in your calculator N is equal to 4, payment is equal to 80, future value is equal to 1,000, the interest rate, if you put in equal to 10%, it would come out to be 936.60. You put in 9.5%, it comes out to be, the new price is going to be 951.93. What we did over here is we said the change in price was 15.16, so the new price is equal to 936.60 plus 15.16, which is equal to 951, and there's some rounding in here, 77. But note, I'm off just a little bit. 93 and 77. Why am I off a little bit? Because this is an approximation. This is not exact. This is an approximation. Now I'm going to attempt to draw what that would look like. Let me take a pause while I try to draw that. Okay, so no comments on the poor drawing right here. But the red line, this red line represents the actual price of the bond. So let's say we start out right here and say given the yield to maturity of 10%, that will give me a price of 936.60. If yields go down, bond prices go up, and they go up along this red line. If yields go up, bond prices go down, and they go down along the red line right there. What duration does is it's the first derivative. If you're thinking about calculus, it's the first derivative of price, but it draws a straight line tangent to the point right there. And so a change in yield, if we go down from 10 to 9.5, then it says the price goes up to the purple line, the price goes to there. But in reality, it goes all the way up to the red line, so there's a little bit of a difference, right? So it's not an exact match. This is just pretty close. If we want to get a little bit more exact, we can do something like this. We can say the change in the price of the bond is equal to minus D star times the change in the yield times the initial price. I'll have initial price is P0 plus 1/2 times convexity, and I'll explain what convexity is in just a second, times the change in yield squared. Alright, convexity is the curvature of the line. So would you rather have a bond that has, let me see if I can get a slightly different color here, it won't be too bad. Would you rather have a bond that follows the green price or the red? So if yields go up, so yields, let's say, go to this point right here, then would you rather have your price on the red line or the green line? Well, the green line, because it's a higher price. If yields go up, the bond that follows the green line has a higher price. If if yields go up, the price goes down, but it doesn't go down as much, is what I meant to say. It still has a higher price. If yields go down, prices go up, and the price on the green line, it goes up even more than the one on the red. This is the measure of convexity. Convexity is the curvature of this line. And I want that line to be as curved as possible, because when yields go up, the prices, yeah, they go down, but they don't go down as much. When yields go down, the prices go up, and they go up even more the curvature of that line is. This measure of convexity is always positive. Anything squared is always positive. 1/2 is always positive. So this portion is always a positive number, so you want as much convexity as possible, because that's going to make your price change be more positive. I mean, this portion may overwhelm it when yields go up, yeah, and bond prices go down, but this makes them go down not as much. Or if yields go down, it makes bond prices go up even more. And that's basically what we have here. I want you to work in chapter 16, work problems 3 through 5 and 7 and 8. Read the whole thing except skip from page 523 to 526, the portion on duration and convexity of mortgage-backed securities. So just that portion, duration and convexity of mortgage-backed securities, and also skip section 16.4. I will give additional problems, not in the book, but I'll make my own problems and we'll work through those in class Thursday.